Yesterday, we did the first couple of pages of section 7.4 notes. Here are the remaining examples that we did not get through in the remainder of class. You will have a copy of these. They're also posted on Schoology, but I wanted to talk you through them in case you had any questions. So first off, let's say you started your own business on the weekends. The business can bring you a profit on Saturday and Sunday based on various independent scenarios. Now, the first thing I see is that word independent. That's very important because as long as your variables are independent, you are allowed to combine the means, but more than that, you're allowed to combine variances and standard deviations. Okay, in general, independence is required to combine variances and standard deviations, but it is not required for means. So the first question says their profits and respective probabilities for Saturday and Sunday are listed below. I notice that I have two random variables. X is numerical. Also, it is a probability distribution. Notice that 0.1, 0.5, and 0.4 add up to 100%. So does 0.2, 0.3, and 0.5. So both add up to 100%. Calculate the mean and standard deviation of each distribution. I did this in my TI Inspire calculator. I created a spreadsheet with X and with P of X. Once I had the spreadsheet in there, I calculated the one variable statistics using X as my variable and P of X as my frequency list and received both of these information from the readouts there. So I got a mean of X of 66. When I look at, and that seems to make sense, most of my data is in the 50% or $50 range. So it makes sense, and it's a little higher than 100 than 10, so 66 seems like a reasonable value. Standard deviation is $30.07. For Y, I did the same thing with a second spreadsheet, and I ended up with 62, which also seems to make sense. Most of my data is in the 80, but it's about half and half, so it makes sense that it's in that range. All right, so I have my value here, and these are my two independent ones. So it says compute the following, and the first is the mean of X time plus Y. So we know from our rules from yesterday that means behave, and so that means I can do the mean of X plus the mean of Y, and that just requires me to sort of add those two together. 66 plus 62, the combined profit, average profit from the 2 days is $128. To find the mean of X minus the mean of Y, again, means behave as predicted. I can take the mean of X minus the mean of Y, so I take my two numbers and subtract them and get a combined mean of $4. To calculate variance and standard deviation, for variance, the variances should add, so the variance of X plus Y is the same as the variance of X plus the variance of Y. That is not a number I have from my readout. So in order to find the variance, I have to take my standard deviation and square it. So since the standard deviation is 30.07, the variance is going to be 30.07 squared. Similarly, for the standard deviation of Y is 22.72, so the variance of Y would be 22.72 squared. That gives me a sum of 1,420.4. So that would be my variance. As far as the unit goes, that would be in dollars squared, so I didn't write the unit there. To find the standard deviation, I need to square root the variance. So I square root, and I get a standard deviation of 37.69 for the combined profits. So again, you have to square them and then take the square root of the result, which is not the same thing as just adding them together. And that's very obvious in this situation. If I take 30.07 and add it to 22.72, I am not going to get $37.69. So squaring and then square rooting the result gives you a much different answer than just adding the two square roots together. For the standard deviation, the variance of the differences, remember that because this is really like a -1 times y, that can be a coefficient, which means you're going to square it. -1 squared is a +1. So this is the same as above. So the rules for differences and sums of variances are the same. So I'm going to get the same answers as my one above there. Okay, at the bottom, I want to know the mean of 4x. This is a single variable, so I'm going to behave as normal, 4 times the mean of x, and I get $264. To find the variance the variance of 4x, remember the coefficient gets multiplied. Okay, so my 4 is a multiplier, actually gets squared as well as my variance in there. 4 squared gives me the 16. I'm going to take my standard deviation and get 30.07. I have to square that. I get a combination here of 14,467.3. To get my standard deviation, I'm going to square root that value and get 120.28. Now, interesting to note in this question, since this is a standard deviation, I'm not combining multiple variables, so I don't have to play it by the exact same rules as combining x and y. I can just multiply the standard deviation of x by 4 and I would get that same value. 30.07 times 4 does give me 120.28. Then I could have worked backwards from the variance and squared it to get this particular value right there. All right, the next question says, for each million tickets sold, the original New York lottery awarded 1 $50,000 prize, 9 $5,000 prizes, 90 $50,000, I cannot say this, 90 $500 prizes, and 950 prizes. Describe the possible winnings in terms of a random variable and calculate the winnings, the expected value of a single ticket. All right, so I'm going to start off by defining my variable. X is the amount of winnings, and I know from the problem that you can earn $50,000, you can earn $5,000, you can earn $500, $50, but also not everybody's a winner, so you could also earn $0. As far as the probabilities, there is 1 out of 1 million $50,000 ticket, 9 out of 1 million $5,000 tickets, 90 out of 1 million $500 tickets, 900 out of 1 million 50. And then I took $1 million, 1 million tickets, minus 1, minus 9, minus 90, minus 900. Okay, and that gave me 999,000 losing tickets out of that 1 million. Now, you could just put those in as decimals. I just went ahead and left it as 1 out of 1 million. Later, it says find the expected values. Remember, expected value is the mean, the average price. I did this in my TI Inspire calculator. So I made a column for X where I typed in 50,000, 5,000, 500, 50, and 0. And I made a P of X column as well, where I did 1 divided by 1 million, and I just typed in 1 divided by 1 with 6 zeros behind it. 9 divided by 1 with 6 zeros behind it. 90 divided by 1 with 6 zeros. I typed it literally in as a fraction to do this. After running the one variable statistics, we get an expected value or a mean, and it's going to show up as an X bar in that one variable statistics of 0.185. Now, since these are winnings, it's about 19 cents. So what that means is the average ticket wins 19 cents. Now, obviously, there are no tickets that could actually win 19 cents. You're either going to lose or you're going to win some money. But on average, if you average out all the tickets, you're going to get 19 cents winning. So it says if the tickets are sold for 50 cents each, how much could the state of New York expect to earn for every million tickets sold? Okay, so people pay 50 cents to buy a ticket. On average, they win 19 cents. So if we were to take those values and subtract them, basically that's talking about the New York Lottery's profit on the value. So the difference between these two per ticket is about 32 cents. Okay, so if you take 50 cents and subtract that value out, this is what we're going to get left over. Now, I'm going to take and subtract my two values. That tells me the profit per ticket times 1,000 tickets. They're going to make $3,115 off this exactly. And actually, I think I've got this number wrong. I think it should have been 31 cents. 50 cents minus 19 cents. We have a profit of about 31 cents per ticket. All right, suppose, I'm moving my screen around. Aren't you excited that you're listening to this video? All right, here we go. Suppose that the average SAT math score is 625 with a standard deviation of 90. The average SAT verbal score is 590 with a standard deviation of 100. The composite SAT score is determined by adding the math and verbal portions. What's the mean and standard deviation of the composite scores? Now, in this case, composite score is going to be the math score plus the verbal score. So we should be able to just add the means together to get that composite score. The mean of math is 625. The mean verbal is 590. That gives us a mean composite score of 1215. And remember, independence is not a requirement for adding means. You can do that with means basically no matter what your variables are. However, with standard deviation and variance, these are not independent. The problem doesn't say anything about those two scores being independent. So if we use what we actually know about SAT scores, I know that SAT scores are not independent. I know that your verbal score and your math score happen to be related. Most people who do well on one will also tend to do well on the other, and vice versa. Okay, so I don't believe that these are independent situations, which means that since they're verbal pairs, math and verbal pairs, I cannot determine the standard deviation in this case. Now, if they were independent, or if you wanted to assume that they were independent for sake of the problem, I would say something like this: that I do not believe they are independent, therefore we cannot calculate it. However, if they were independent, I would do the following, and you could still solve the problem by taking the standard deviations and squaring them. 90 squared plus 100 squared. Okay, 90 squared plus 100 squared. That would give you your variance, and then you could take the square root of that to find the standard deviation if they were independent. But I think you need to show a lot of caution in this problem due to the context. If this was a multiple choice question and it didn't say anything about my variables being independent, I would be most tempted to go with an answer that would say something like cannot be determined, or E, none of the above, or something like that. All right. A local high school requires seniors to take a comprehensive exam covering mathematics, science, and English prior to graduation. Each section is graded separately by a person who teaches the corresponding subject. The mean and standard deviation for the time required to grade each section is given below. All right, so the time it takes to grade the math, the time it takes to grade the English, the time it grades the science, there's my mean and standard deviation. Assuming the time required to grade any one section is independent of the times to grade the other two sections, what are the mean and standard deviation of y, the total time to grade the exam? Now, I want to note that these exams are paired up, and you might argue, but Mrs. Leahy, you said mathematics and science and English. That would be like saying math and verbal from the last problem. Since these belong to a student, shouldn't they be independent? Or not independent, since they are a paired situation. In this case, it's not quite the same. Obviously, if we were talking about scores, their scores would probably be dependent. I think we could assume that somebody who did well in math and science and English would just do well across the board. Okay, and maybe not so on the other tasks. The deal here is that this is time. Okay, the time to grade it. So because these are graded by 3 different people, and assuming independence in there, this is a different situation. If these were the mean score on these, I would be tempted to answer very similarly that I did to the last one. But time is not quite the same. All right, so to find my mean, I'm just going to combine my means together. A mean of math, mean of science, mean of English, and I get 15.8 minutes. Okay, remember this could be interpreted that the average time to grade an entire exam, the expected value to grade an exam is 15.8 minutes. To do our standard deviation, remember we have to add the variances. Since we were not given the variances, we were given the standard deviations. You have to calculate them each separately. So 0.4 is my standard deviation, which means 0.4 squared is my mean. And similarly for, 0.4 squared is my variance for math. And I would do the same for science and for English. This gives me a combined variance of 0.5. So to take the standard deviation, we would take the square root of that value. I didn't put a unit on this, but it should also be minutes. Okay, so remember the standard deviation has the same unit as the mean. All right, last example. 2 random variables x and y are independent. Boy, that's an important word. That means that both of these scenarios are okay. The means and standard deviations are given below. What values of the mean and standard deviation of 2x plus y? So for the mean, it behaves just like we would predict. The mean of 2x plus y is the mean of 2x plus the mean of y. And if I'm doubling the x, I'm also doubling the mean. So I should be able to, with a little bit of substitution here, 2 times the mean of x, 6, plus the mean of y, 8, gives me 20. So I knew after doing this problem that I could cross out A and B because they had the wrong mean. I know it's got to be one of these. Okay? The next thing I'm going to do is I'm going to calculate the variance. So to get the variance of 2x plus y, that would be the variance of 2x plus the variance of y. The variance of 2x, however, has a multiplier, and when you're dealing with variance, that multiplier gets squared. Okay, so it's 2 squared and not just 2. 2 squared, not just 2. Okay, so very important right there. Now I can put these values in. 2 times the 0.5 squared plus 0.6 squared is 1.36. That's my variance. And I'm going to take the square root of that to get my standard deviation. And that's answer choice E. All right. So for homework, you need to be working on section 7.4. Those problems are due the last day I see you before break. Okay. If you have any questions, please email me. Hopefully this video helped for any of those who watched it. If you need to email me with questions, I can answer that. There's also SRT next week.